Alright, so we have this formula. Area is a half times base times height. We're familiar with that. That works great over here, where the height is perpendicular to one of them, but it doesn't work so well for things like this. Okay, so how does it work when you have either an acute or an obtuse triangle? Well, if we call this the base, then we can still use the formula. We can still say, well, the area is going to be a half times the base times the height. What you end up with then, though, is, in this case, we get a half, and the letter for the base here is what? Is C. And what's the height? Well, the height is over here, right? But can I express the height? So is there a way to express the height in terms of the parts of the triangle that we have? So can we express the height either with A's, B's, and C's, or the angles that are related to it? And so hopefully you are saying yes, because if I stand in this angle over here, the height would be what? It would be part of the sine, right? So the sine of angle A is the height divided by the base. That means that the height would be B times the sine of A. Are you guys okay with that? Like if I cross multiply here, put this over 1 times H is height, B times sine of A. So instead of writing the height, you could write what here? B times sine of A. So this is another formula for the area of a triangle. And for some reason the book, and I'll rewrite this a little bit, so the area is often abbreviated with the letter K. And so what you'll see is it's usually written this way: B times C times the sine of A. Are you guys okay with that, sorta? Alright. It would actually work the same way over here. Are you okay with that? So this was for the acute triangle, right? Yes? No? Okay. It also works for the obtuse triangle because here, so the height again is perpendicular to C, so we would be writing the same thing, and then you could still write, now you have angle A over here, you would just do the same thing, you get H over B, and it works the same way in the obtuse triangle. The other thing that you have to keep in mind is that you can rotate these letters any way that you want to, right? So what I mean is that instead of calling this A, I could call that C, I could make this A, and I could make this B. Is that right? So all these letters would rotate as well. So this now would be B, this now would be A, and this would now be C. So if I rewrote this whole expression, does it make sense that I can come up with any of these? That instead of a half times B times C, I could have a half times A times B, and then the angle ends up being sine C. Or the area could also be a half times, so we used A and B, we used B and C. Which combination did we not use yet? A and C, and then it will be the sine B, right? Okay, so you get A, B, and then the missing side would be what you take the angle of, or the sine of the angle. Are you guys okay with all that? Okay, so that's a different formula based on different triangles and probably a slightly different information that you have. Okay, so how does it work? Well, so let's see what we have. We have one angle, right? So if I have to use a formula here, the only angle that I have is A, so this would have to be a half times B times C times the sine of A. Are you guys okay with that? Okay, so since A is the only angle that I have, it will be the sine of 33 degrees here. And do I have the sides B and C? So yes, in this case I have sine B is 5, side C is 7. So I can multiply this out. So this area will be a half times 5 times 7 times the sine of 33. You get a calculator, and it gives you 9.53. And if it was centimeters, let's say it's centimeters, it would be centimeters squared. Yes? All right. What if you don't have the right combination? So what I mean with that is this. We have this sine, alright, so we have two angles here, right? And how many sides do I have? I have only one side, don't I? So the problem here is that whichever formula I pick, how many do they use? Well, if I use A and B, then I need the sine of C. Well, in this case, I have the sine of C. I have 40 degrees. I know that A is 12. Do you know what length B is? Do we know B? No. Well, what then if I used, what if I had used this one? A half, so I know A. So what about if I use this one? Would I know the information needed at this point? Do I know what length C is? Yes? No? Okay, so I would just say here is I'm missing one side length, right? Does that make sense? How can I find it? How do you find either B or C? Yeah, you use the law of sines first. So 12 divided by the sine of 115. And which one do you want me to use or find, B or C? B? Okay, well, B would be divided by the sine of 25. So that means that side B would be 12 times the sine of 25. So I'm cross multiplying. So these come together. And then B would be combined with the sine of 115 divided by the sine of 115 degrees. And then you get a calculator and figure out that B is how much? 5.6. Okay, so there's an extra step here. This is what I meant earlier today when I said, well, we'll have to use the law of sines and the law of cosines. And usually you can get by with the law of sines in these problems. And then now you fill in. Make sure you pick the right one. So what did we find? We found A, which was 12, right? We found B, which was 5.6. So if I used A and B, then I better use the sine of angle C, and that would be the sine of 40 degrees. Okay? Plug all this in, multiply it out, and hopefully you end up with this. Slight rounding error, which is fine. If I rounded it to 1 decimal, we'd have the same answers either way. Okay? We're alright with that one? Okay. Alright, so that's a new situation for us where we're not given perpendicular, so we're not given a right triangle, so now we can find the area a different way. Well, sort of two different ways. So what if you were given the three sides only? Alright. So the long way here would be to go find one of the angles, right? And then do a half times A times B times the sine of that angle. And to find one of these angles, we would have to use what? So method one would be, we would have to find an angle, right? Find one angle. Since we're given three sides, you would have to use the law of cosines, right? We don't really need to worry about which angle we find here because the law of cosines always gives you the right angle anyway. And then you could still use a half times A times B, and in this case, I guess we would be finding the sine of C, and you get an answer. Okay, so that's method one. You are more than welcome to do that method. Okay. Fortunately for you, somebody a long time ago found this other formula for that as well. If you are given three sides, you can use Heron's formula, which ends up being this. And the only thing that's a little weird there is, what in the world does S stand for? Well, S would be defined over here. And so if I give you a set of formulas, then like this blurb would sort of be on there. So it would also define for you what S is. But S is called the semi-perimeter, with semi in this case being half of the perimeter. Because the perimeter of the triangle would be A plus B plus C, right? Yes? Then you take half of that, and that's what S represents. And usually we would do that first so that you don't have to fill in all these numbers over here. So if I do it method 2, so the second method would be using this beautiful little formula that we were given. I would find S first. I would say, well, S is a half times A, which would be 5, times B, which is 4, times C, which is 7. So that's, I got stuck on my math, 70? Yes? No? Yeah? Okay. And then fill in the other stuff. So it's the square root of 70 times 70 minus A, which is 5. And then it's 70 minus B, which is 4. And then it's 70 minus C, which is 7. And multiply this mess out. Take the square root and grab your calculator and figure it out. So the area of this triangle I made a huge mistake in this, didn't I? There's no way that that was right. What did I mess up on?
Oh, it's adding?
Yeah, it's a half times A plus B plus C. So I am sorry. We're going to have to erase some of this. I will erase all this. Trying to see if you guys are awake after the break. I got an area of over 4,000, and I'm looking at the triangle going, it's 4 by 5 by 7. That seems a little strange. Let's try it this way. A plus B plus C. So 5 plus 4 plus 7, and then take half of that. That should be a little bit better. So that's 16. Half of 16 is 8. Let's try it with an 8. So it's the square root of 8, and then it's 8 minus 5, and 8 minus 4, and 8 minus 7. And that looks a little bit more friendly. So 9.8. I got 9.8.
Oh, yeah.
And again, I guess I haven't been good about giving units in the problems, so let's just make it meters squared for this one. Okay? Sorry about that first mess. So you'll get that formula. I don't want you to have to sit there and memorize these. The same thing with the half times A times B times sine C, although I think that one, if you do a couple of problems, you'll catch on to that one pretty quick. So, alright. This is sort of a off the beaten track just a little bit. The book does a pretty good job of explaining this, so but I just want to run through this. So calculators aren't the end of the world, or that, well, they aren't the solution to all the problems in your life in terms of math. For example, if I gave you this, if I gave you these sides for a triangle, and you just have to believe that I mean, I know it's an extreme triangle, but it is a triangle that's possible. If I use the formula that we just worked on, what would you end up with? Well, you would do a half times, and then you get, so there are how many? 1, 2, 3, 4, 5, 6. So you do the semi-perimeter like this, and then it's 1, 2, 3, 1, 2, 3, 1, 2, 3. And then it's 9, a bunch of these 9s, so 1, 2, 3, 4, 5. And then a 7, and then a 9. And then and you do half of all of that, you multiply it out. And did anybody do it? What did you get? If you have a calculator, do this on your calculator, because it's sort of interesting to see what happens here. See what you can get for the semi-perimeter.
I got 100,000.
100,000 or 1 million?
I mean,
Anybody else do it? If you did, you do, that's what you get. You get 1 million, okay? So then what happens? You fill this in and what do you get? So the area of the triangle would be the square root of 1 million. And then you do what? Minus a, which is? And that's 0. And then you're going to multiply it by some more stuff. And what's 0 times anything? And so you get the square root of, which is? And that area is triangle, or that triangle apparently has an area that's worth 0. Okay, that's wrong. Okay, the reason for that has to do with the ability of the calculator to carry enough decimals, or numbers actually in this case. So I think the book says, let me find out what it says in the book, I think most calculators store 12 to 14 numbers, or digits I should call it. So with the numbers that I gave you, especially that 999,999.9999979, that's a lot of digits. So it has trouble carrying that many, and so it has to round at some point. So there's another way that you can rewrite that formula. And if you use that one, so this is just Heron's formula rewritten, okay? We don't have, I'm not going to go through how you rewrite it that way, but this is another form of it, and if you do it this way, then the answer will work for extreme cases like this. So in this case you would fill in all the numbers the long way, so, and including the parentheses, because it's the adding and it's the grouping of the numbers that makes this work. So hopefully you're getting the idea here. I'm not going to fill in the whole thing. Thought this was neat to see once, so I'll fill in the first one. Well, this isn't quite 1 million, is it? 79 plus 29 isn't going to be 1 million. Yeah? And then group that, get a whole bunch of other stuff. Huh? Well, by grouping it this way, the calculator is able to carry these to the right number of digits, because by adding this, the number of digits doesn't change. And then with here, adding this one at that point, the number of digits doesn't change. So it always is carrying 14 digits, which is the maximum pretty much it can carry. Does that make sense? So it's not rounding, whereas here it had to round because it's supposed to do all of this and then multiply by a half, and we ended up with too many digits. And if you do this triangle's area is actually, I think it's exactly 1, which is the right area. That triangle has an area of 1. Okay, I think that's it.